The code block for an if statement can contain any code that would be valid when used outside of such a code block. One consequence of this fact is that it is possible to nest an if statement inside of another if statement. Let's consider why both the outer and inner conditions must be true before the inner code block runs. The inner if statement is part of the outer if statement's code block, so its code will be completely ignored if the outer condition is false. That means the inner if statement's code block will not run even if the inner condition is true. In this example, the conditions for both the outer and inner if statements is true, and both console logs run. If I change the outer condition to false, neither console log runs. It makes no difference here if the inner condition is true or false. If I make the outer condition true and the inner condition false, the first console log runs, but the second one doesn't. Because the outer condition is true, the code block associated with it runs, and that yields the first console output. The inner if statement also gets evaluated, but it has a false condition, so its code block does not run. Because both the outer and inner conditions must be true for the inner code block to run, nesting can be used when you need multiple conditions to be true at the same time. One example in which this is useful is for numerical ranges. For example, a candidate must be between the ages of 18 and 35 to enlist in the United States Army, so we can express that in code like this. 15 is not greater than or equal to 18, so the else block runs. If I change the age to 21, the age is greater than or equal to 18, so the code in the if block runs. The 21 is then compared to see if it is less than or equal to 35, and it is, so we get the output of you meet the age requirements. Note that 15 is also less than or equal to 35, but the inner if statement is ignored when age is 15 because that makes the outer if condition false. Changing the age to 42 results in the output of you are over the age limit. 42 is greater than or equal to 18, but it is not less than or equal to 35. There is an alternative to nesting if statements when the sole purpose of the nesting is to test the values of multiple conditions simultaneously. This involves the use of logical operators. These are operators that can be used on Boolean values to yield a Boolean result. The first logical operator that we will look at is the logical AND operator, which is written using two ampersands without any space between them. The first console log outputs true because both conditions are true. The other three output false because the AND operator only outputs true if true values appear on both the left and right side of the operator. Let's look at how this is used with an expression. This outputs true if the age is between 18 and 35, and it outputs false for all other values. Because using the AND operator on two expressions yields one single Boolean value, we can use this as the condition for an if statement. Notice that this approach involves less code than nesting and can be easier to read, which is why this approach is generally preferred. However, it also doesn't distinguish between ages that are too young or too old. It only identifies if an age is within the range or not, so using the logical AND operator is not an exactly equivalent substitute for using nested if statements. The next logical operator that we will discuss is the logical OR operator, which is written using two consecutive pipe symbols. On the United States keyboard, the pipe symbol is located on the same key as the / and requires using a shift key to access it. This code outputs true for the first three console logs, and it only outputs false for the last one, because the OR operator outputs true when either or both values are true. It only outputs false if the values on both sides are false. Here is an example using the OR operator in an if statement. This code block runs if either of the variables has a true value, and it doesn't matter which one or both. The code block will only not run if both variables are false. The equivalent code written without using the OR operator involves some redundancy. This is not only more verbose, it can also lead to inconsistencies if you update one code block and fail to update the other. The final logical operator that we will look at is the logical NOT operator. It is written using a single exclamation mark and it precedes the value that is being negated. Note that this differs from the other logical operators in that it applies to only one value and it comes before instead of being in between. The not operator performs a logical negation. The negation of true is false and the negation of false is true. Because the not operator only operates on a single value, it is necessary to use parentheses when negating an expression. This outputs false because the expression 3 less than 4 is true and the negation of true is false. This can also be used as a condition for an if statement. Failing to include the parentheses can yield a surprising result. You might expect this to output false because 3 less than 4 is true and the negation of true is false. What actually happens is more complex than that. It involves type coercion, which we discussed in the previous video. The logical negation of the number 3 is false. Recall that all numbers are truthy except for the variance of the number 0 and NaN. That means the number 3 is a truthy value and the logical negation of that is false. This leads to a comparison of false less than 4. Another type coercion happens here because a boolean can't be compared as less than a number. The false value is coerced to a number which is 0. So the final comparison that actually happens is 0 less than 4, and that is true. If you think this kind of type coercion analysis is complicated, you are not the only one. This could all be avoided by using the parentheses. This causes the expression inside the parentheses to be evaluated first before the logical negation is applied. 3 is less than 4, so the expression inside the parentheses is true. The negation is then applied to true, which yields the value of false. Note that it is possible to use multiple logical operators in a single expression. 3 less than 4 is true, but it's negated, so the expression to the left of the OR operator is false. 7 is greater than 5, so the expression to the right of the OR operator is true. Only one of these two expressions needs to be true for the OR operator to yield a true result, so this outputs the Boolean value of true. Using this expression in an if statement looks like this. There is still more to using if statements beyond what we covered in this 3-video series, and there are other conditional statements we haven't covered yet. But we are going to temporarily change topics and cover mathematics in the next video. Don't worry if you hate math, we won't need to calculate anything. What we will cover is how to write mathematical expressions in your code for the JavaScript engine to calculate for you.